Hello, students, and welcome to our October 6th edition of Algebra. Our Do Now asks us to respond thoughtfully to a question about emotions. So you want to think carefully about that. Our objective will be to solve equations with variables on both sides of the equal sign. So they are equations, we'll have an equal sign, but we will have variables on both sides. Our essential question today is, what are the steps necessary in order to solve an equation with variables on both sides? And our assignment will be to watch the October 6th video while we do lesson 2.2, solving equations with variables on both sides. For our exit ticket, we want to focus on our newly added step. So what is our newly added step that we need to do when solving equations with variables on both sides? And for homework, we'll do that related homework, solving equations with variables on both sides. A few people have asked for a bonus assignment to apply toward the last test you had and bring those scores up. I think that would be great. I think the extra practice is always a really good idea. And I think when you self-correct and reflect on your work, you really learn well. And I'm happy about that. So I am going to offer that. And then I'm also going to have a poll, a class poll, just a little thing I'm going to do on Wednesday. The poll is mandatory for everybody, but the bonus assignment is optional. So you can decide whether or not you want to use that to bring your grade up. I know a lot of you will, because you're very good students. It's been a real joy to work with you. Even though our year is so young, I'm already learning so much about you. So here we have our do now. Choose one positive emotion. Now, name other nuances and versions of that emotion. Is being specific important? For example, I could think of the word happy, but a more nuanced version of happy might be fulfilled, or it might be joyous, or it might be exuberant. And all of those things mean something different. And if I said to you, I'm feeling very fulfilled, you might have the impression that I have a really kind of internal happiness. Or if I say I'm exuberant, you might want to say, wow, what happened? Did you get a raise, or did you have another grandchild, or some big exciting thing? So different versions of our emotions really help us to not only understand but communicate to others what we're really feeling. That's always a good thing. So I want you to think about that for a few minutes. When we get to our exit ticket today, we're going to focus on that one extra step that we must take in order to solve an equation with variables on both sides. So we'll get to that in a few minutes. So, as you guessed it right now, our topic is equations with variables on both sides. So, what do we need to do when we solve an equation? What are our steps? And when there are variables on both sides? So, there's a lot of similarities. We are going to distribute if necessary. It's not always necessary. We'll look for those grouping symbols, parentheses in particular, when we distribute. After we distribute, we're going to combine like terms. And here's our new step. This is something new. We will move the variables to one side of the equation. So that's an important step we want to keep in mind. And then, of course, as always, we will use all the tools in our algebra toolbox, inverse operations, and etc., to solve the equation. So let's get started with our first two equations. we have 5y minus 8 equals 3y plus 12. So I generally will move the lesser variable over to the greater variable. There are times when I might not want to do that, but in general, this equation can be solved by moving 5y to the right or 3y to the left. Either way, you will get to the correct answer. I just like to keep my variables positive if I can, so I don't have to divide by -1 at the end of the day. So I'll start by, I'm going to subtract 3y. Let's get those variables over here. Okay, so 3y minus 3y is 0. So on the right side, I have equals 12. On the left side, 5y minus 3y is 2y minus 8. So now we're going to solve this equation just like we have all the other multi-step equations. We're going to add 8 to both sides. 2y equals 20. And now I look and I say, what is happening to y? Y is being divided by 2, so I will multiply by 2. Whatever I do to one side, I do to the other. And I now have y equals 20 divided by 2, which is 10. And as always, you can substitute your answer, reevaluate your equation, and see if you get 10 equals 10. So work on that. You'll have the same number on both sides. So let's see. 5 times 10 is 50 minus 8, which is 42. 3 times 10 is 30 plus 12. That equals 42. And our answer checks. So y equals 10 on both sides. Let's do number 2. We have 6x plus 14 equals 12 minus 8x. I'm going to go ahead and, I have negatives on both sides. I'm going to move negative 8x over to the right by adding it. So whatever I do to one side of the equation, I'll do to the other. So negative 8x plus 8x equals 0. So the right side of the equation just got pretty simple. Negative 6 plus 8 is 2, so we have 2x plus 14. Let's get a new color. So let's subtract 14 from both sides. And 12 minus 14. Sorry, it's negative 2. I have 2x on the left side. 2x equals negative 2. I'll divide both sides by 2. And x equals negative 1. Okay, let's scroll down. Let's try a couple more. 7k equals 3k minus 36. The first thing I'm going to do here is subtract 3k from both sides. 3k minus 3k is 0, so I'm left with negative 36 on the right side. On the left side, I have 4k. K is being divided by 4, so the next thing I want to do is being multiplied by 4, so I want to divide by 4. Whatever I do to one side, I'll do to the other. K equals negative 9. So, let's see, 12 minus 2u equals 9u plus 45. I'm going to move the u's over to the right. So I will add 2u to both sides of the equation. That gives me 12. Now, I canceled out even the negative sign, so don't get confused, okay? I canceled that out with this plus 2u. So now I have 12 equals 11u plus 45. Now, let's take this 45 and move it over to the left side by subtracting, using that inverse operation. So this equals 0. So on the right side, I have 11u. 12 minus 45 is negative 33. So I see that u is being multiplied by 11, so I will divide by 11. Whatever I do to one side, I do to the other. So now 11 over 11 equal 1, and u equals negative 3. And number 5, I think I have negative 1m. Remember, that's an invisible 1 there, so don't get mixed up with that. So we've got 11 minus m, or minus 1m, equals 51 minus 6m. So I'm going to move 6 m's to the right because that's a smaller number. So I'll add 6m. I'll add 6m here. So negative 6m plus 6m equals 0. So the right side of my equation is just 51. Negative 1 plus 6 is 5m. So I've got 11 minus 5m equals 51. Now I'll subtract 11 from both sides. So 11 take away 11 is 0. I have negative 5m equals 40. Now what's happening to m is being multiplied by negative 5. So I'm going to divide by negative 5. And that will give me m equals negative 8. No, I'm dividing by positive 5. Sorry, this should be positive. So m equals 8. Yeah, when I had 1m, negative 1m plus 6, this should be positive. And that makes this a positive 5. Dividing by positive 5 makes that a 1. M equals 8. Okay, let's go on to the next set. Negative 10k plus 1 equals 40 minus 7k. So I'm going to take the 10k and move it, the negative 10k, I'm going to move it to the right side by adding 10k to both sides. That way I'll turn this 7k, I can turn that positive, which is a good thing. So I have 1 equals 40 plus 3k. Now I will subtract 40 from both sides. And that gives me negative 39 equals 3k. And now 3k is being multiplied by 3, so I will divide by 3. Whatever I do to one side, I do to the other. And on the right side, I've got k. On the left side, I have negative 13. So now remember, we can have the variable on the right like this. That's okay. If you wanted to rewrite this, the symmetric property would say that's okay. You can write k equals negative 13. So if that makes you feel better, go ahead and do that. So go ahead and try to finish these up, pause the video, work the problems, and then come back. Okay, are we ready to do some more problems? On this one, we need to distribute which means we're going to multiply through the two terms in the parentheses. Remember, terms are separated by addition and subtraction. So we have 3 times 6 is 18p. 3 times negative 1 is negative 3 equals 11p minus 45. I'm going to move the 11p over to the right by subtracting it from here and from here, both sides of the equation. 11 minus 11 equals 0. So I have equals negative 45 on the right side. On the left side, I have my negative 3, and then I have 18 minus 11, which is 7p. Now I want to isolate 7p, so I'll add 3 to both sides to keep our scales of algebra justice in balance. So on the left side, 7p equals negative 42. Now I have p is being multiplied by 7. The opposite of multiplication, or the inverse, is addition, so I'll divide by 7. Whatever I do to one side, I do to the other. And p equals negative 6. In number 8, they're getting a little more difficult. We have to distribute in two places. We have to distribute the 2 through 4w minus 1, and we have to distribute the negative 10 through w minus 3. So let's get started. So this will give us 8w minus 2 equals negative 10w. Negative times a negative is a positive, plus 30, and then I still have my plus 4. So let's start combining some of these terms. We distributed, now we want to combine these terms. So I can combine the 30 and the 4. So that's 8w minus 2 equals negative 10w plus 34. Now I can start isolating. Well, we need to move the variables to one side or the other. I'm going to move the negative 10 by adding 10w, and whatever I do to one side, I do to the other. So on the right side of the equation, I have 34. On the left side of the equation, I have 18w minus 2. So w. So let's add the 2 to both sides so we can isolate that 18w. (18w) equals 36. Now, w is being multiplied by 18, so I will divide it by 18, doing the same thing to the other side. And I'm left with w equals 36 divided by 18 is 2. Let's look at 9 and 10. So I see we're going to combine like terms and one distributive opportunity. So 9 times m and 9 times negative 3. So that's going to be 9m minus 27. So positive 9 times negative 3 is negative 27 plus 3m. I cannot combine the 3m and the 7m because they're on different sides of the equation. So they'll have to wait for a minute for me to use inverse operations. Equals 7m plus 43. So what can I combine here? I have 9 plus 3 is 12m, and then I have my minus 27 equals 7m plus 43. Now, I think what I want to do is move my 7m's to the right. So I'm going to subtract 7m on both sides, which would give me 5m minus 27 equals 43. And now I'm going to add the 27 to both sides. Which will give me 5m equals 70. And now I have m is being multiplied by 5, so I will divide it by 5, and then I'll divide the 70 by 5, and then I will have a final answer of m equals 14. Okay, they're getting a little more difficult. We can handle this. We're going to distribute -7. We're including the negative sign through 2a and 3. So -16 and -7 times 2a is -14a. -7 times 3 is -21 equals 23 minus 2a. Okay, I see where we can combine like terms here. We can combine -16 and -21. So we're going to start with our -14a, and -16 minus 21 is -37 equals 23 minus 2a. So now I'm going to, I think I will add 14a to both sides, keep it positive. So this makes 0. So now I have -37 equals 23 plus 12a. Now I want to isolate the 12a, so I'm going to subtract 23 from both sides. And I will have 7 and 3, 10 for 60, -60 equals 12a. And now I have a being multiplied by 12, so I will divide by 12 and do it on to the right side. And that will give me a equals -60 divided by 12 is -5. So let's go down to the last couple of problems. Now we have to distribute in two places. Remember, when you distribute just a sign like that, a negative sign, what we're really talking about is an invisible 1 here. So you're multiplying -1 times x and -1 times -18. So on the left side, we've got 5x minus x. Negative times a negative is a positive, plus 18 equals 6. Now, -2 times x and -2 times 15. So minus 2x minus 24. Now we've got some combining like terms to do. So we can combine 5x minus 1x, which makes 4x plus 18 equals, and we can combine on this side the 6 and the -30. Where did I get that 24? I'm sorry. It's getting late for me. That should be a 30. Okay, we can combine the 6 and the -30 for a -24. So let's bring down a -2x, 6 minus 30, -24. Okay, let's change the color. Something will wake us up a little bit. Let's move all the variables to one side. I'm going to add 2x to both sides to keep the x positive. So now this cancels, and I have 6x plus 18 on the left equals -24 on the right. And what's left for me to do now is So a couple of steps left. I'm going to move the 18 over to the right by subtracting, and whatever I do to one side, I do to the other. So 6x equals negative 42. And now I'm going to divide both sides by 6. So it's a negative divided by a positive over here. X equals negative 7. Last problem, and it might be our hardest, but let's see, just step by step. We'll distribute 8 through y and positive 4. So that's pretty easy. 8y plus 32. Now we're going to distribute negative 2 through y and negative 1. So that would be negative 2y plus 2, because a negative times a negative is a positive, equals 70 minus 3y. We have to combine like terms, but all on the same side of the equation. So that does 70 minus 3y doesn't change, but we do have 8y minus 2y. So that's going to give us 6y. We also have positive 32 plus 2, which will give us 34. And let's finish out the right side of the equation, 70 minus 3y. So I'm going to add 3y to both sides, move all the y's to the left, gather them up there. And that would give me 9y plus 34 equals 70. Now I'm going to subtract 34 from both sides so that I can isolate that term 9y. 9y equals 36. 70 minus 34 is 36. 9 is being multiplied by, y is being multiplied by 9, so let's divide by 9. Whatever I do to one side of an equation, I do to the other. So that leaves me with y equals 4. So if you were to insert 4 here, and here, and here, and evaluate this equation, your answer would check, hopefully. So let's go back up to the exit ticket and the question that was asked of us earlier. What is the new step that we must take in order to solve an equation with variables on both sides? And that new step is that we must move the variables to one side of the equation. I hope, students, you've seen the value of doing your work every day, not skipping days, not skipping the homeworks, because you can see now that every skill builds on the thing we did the day before. We're constantly building this kind of building of algebra with all these little bricks of skills that we're acquiring. So it is a bit of work, algebra, but it really all comes together like a beautiful puzzle. So many of you are working very hard. I'm so proud of you. I want you to keep up the good work. I want you to do that homework, get good at this, and look for those bonus points. I know if you work hard, you can do it.